Welcome student. This is the another class of the chemistry. So in this class what will read? We will read what is percentage composition and what is empirical and molecular formula. Okay, what is percentage composition and what is empirical and molecular formula. So first we will read what is the meaning of percentage composition. So percentage composition equals to mass of that element or constituent present in the molecule divided by the total mass or the molecular mass into 100. Okay, once again, percentage composition equals to mass of that particular element or that particular constituent present in the molecule divided by molecular mass or total mass into 100. Clear? So in this concept, purely numerical questions. Okay, so the first question will solve. Question is calculate the percentage composition of various elements present in ammonia molecule. Okay, so first you see, first we have to calculate. So what is the molecular mass of ammonia? So molecular mass equals to nitrogen 14 and hydrogen 3, so equals to 17 gram. So what is the first we have to calculate what is the percentage composition of nitrogen. So percentage composition of nitrogen equals to, so what is the mass of that constituent element? 14 divided by total mass is 17 into 100. So this is the percentage composition of nitrogen. Similarly, percentage composition of hydrogen. So hydrogen equals to, what is the hydrogen mass? 3 by molecular mass 17 into 100. Okay, or after calculation of percentage composition of nitrogen, yes or no, it is 82 point something value will come. So 100 minus this equals to percentage composition of hydrogen, or 3 divided by 17 into 100 also you will get the percentage composition of hydrogen. Clear now? So in the numerical, first we have to calculate the molecular mass, then percentage composition equals to the mass of that particular constituent divided by total mass into 100. Okay, so this is the first question. Come to second question. Here I have written calculate the percentage composition of water of crystallization in the sample of blue vitriol. So first we know, so second question answer is, so blue vitriol formula is CuSO4 dot 5s2. Clear? So calculate the total mass. So the total mass equals to, yes or no, copper 63.5 plus sulfur how much? 32, oxygen 16 into 4 64 plus water 5 into 8 18 90. Yes or no? So this is the total mass of the molecule. Question is percentage composition of the water of crystallization. So percentage of water of crystallization equals to, what is the total mass of water? So total mass of water is 90. Okay, so 90 divided by, here total mass is 249.5 gram. So 90 divided by 249.5 into 100. So this is the percentage composition of water. Clear now? So like this, what questions are coming. So first we have to calculate what is the molar mass, then we have to calculate what is the percentage composition of which element or which constituent is asking in the question. Clear now? Okay, so this is the meaning of percentage composition of different elements present in a molecule. Clear now? Next concept is, what is the meaning of empirical formula and what is the meaning of a molecular formula? Clear? So first, what is the meaning of empirical? Then we will come to molecular. So empirical formula, shortcut we can write this is EM, empirical formula. molecular formula shortcut we can write MF, molecular formula. Suppose if you take one example of a glucose molecule. So glucose molecule, what is its formula? So glucose molecule formula is C6H12O6. Okay, so this is the molecular formula of glucose. Now if we take 6 common, then it will come CH2O. This is actually empirical formula. So this is the empirical formula of glucose. So what is the meaning of molecular formula? So molecular formula represents the actual formula of a molecule where different elements are present. But empirical formula represents the simplest whole number ratio. The simplest whole number ratio of different elements present in a single molecule. Clear? So this is glucose. Similarly, suppose if we take example of fructose. Yes or no? So fructose also molecular formula C6H12O6. Yes or no? So what will be its empirical formula? Same. Clear? Similarly, suppose if we take ethanol, ETHNOL, ethanol. So ethanol molecular formula is C2H6O, you know, CH3CH2OH, CH3CH2OH. So how many carbon? 2. How many hydrogen? 6. How many oxygen? 1. Yes or no? So can you take any ratio here? Any common is there? No. Similarly, so here we cannot take any common. Similarly, suppose if we take acetic acid. Acetic acid. So acetic acid formula is CH3COOH, okay, or C2H4O2. So this is the water molecular formula. So if we take a common, 2 common, then it will come CH2O. So this is the empirical formula. So just you check, you see. So molecular formula may be different from molecule to molecule. Molecular formula may differ, but maybe for 2 different molecule, empirical formula may be same. You see, acetic acid empirical formula is CH2O. Yes or no? But molecular formula is different. Glucose molecular formula C6H12O6, but empirical formula is CH2O. So that's why. Okay, so that's why different molecular formula may be different, but empirical formula may be same. Okay, so this is the important part you will remember. So that's why this is called empirical formula, this is called molecular formula. So got the idea? So what is empirical formula? Again, empirical formula represents the simplest whole number ratio of different elements present in a molecule. But molecular formula represents the actual formula of a molecule or a compound. Clear now? So this is the meaning of an empirical formula and a molecular formula. Clear now? Okay. So suppose ionic compound, if we take example. So most of the ionic compound, their empirical formula, molecular formula are same. Ionic compound, NaCl, empirical formula, molecular formula same. MgCl2, molecular formula, empirical formula same. Okay. So this is the meaning of empirical formula and the molecular formula. Then another part is, what is the relation between them? So empirical formula, you see, molecular formula equals to N into empirical formula. Molecular formula equals to N into empirical formula. N equals to molecular formula mass divided by empirical formula mass. Okay, so N equals to molecular formula mass divided by empirical formula mass. So can you cancel like this? Mass, FF cancel? Yes or no? No, it is not possible. So that's why, so N equals to molecular formula mass by empirical formula mass. So you see, come to glucose. So glucose molecular formula mass is 180. Empirical formula mass, carbon 12, hydrogen 2, oxygen 16 equals to 30. So what is the N value? So N equals to 180 divided by 30 equals to how much? 6. Yes, we have taken 6 common. Okay, so that's why Remember, empirical formula may be for two different molecules, empirical formula may be same. Molecular formula may be different, but empirical formula may be same. Clear? And the relation is empirical formula, molecular formula equals to N into empirical formula. And N equals to molecular formula mass divided by empirical formula mass. Okay? Then, so on the basis of this concept, empirical formula and molecular formula, I have written two numerical. Okay, because in this part, from this part, maximum time numericals are coming. So you have written, okay, two example. So first you see, first question, a compound contains 4.07% hydrogen, 24.27% carbon, 71.65% chlorine. So if the molecular mass is 98.96, then what is the empirical formula and the molecular formula? Clear? So these are actually 2 mark questions. So how can you solve this? So this type of numerical can be solved by tabular form. So you see how can we solve now. So first we will solve like this. So question 1 answer. First we will write like this, element, 1 column. How many elements? One is hydrogen, carbon, another one is chlorine. Clear? Next one we will write their atomic mass. Atomic mass. Hydrogen is 1, carbon 12, chlorine 35.5. This part we know. Next is what is the percentage of mass given. So percentage of mass in the question given, hydrogen is 4.07. Carbon is 24.27, chlorine is 71.65. This is the percentage. So this is the question. Next we will write what is relative number of moles. Relative number of moles. So how can you calculate the relative number of moles? So moles means given mass by atomic mass. Okay, so 4.07 by 1 equals to 4.07. Okay, then 24.27 by 12, so equals to around 2 point something will come. Let's suppose 2.035. Similarly, chlorine 71.65 by 35.5, so equal to this is also around 2.035. So this is relative number of moles. Then next column is simplest ratio. Simplest ratio. So simplest ratio, how can you calculate? You will remember. So in the relative number of moles, which one is least? 2.035. So divide 2.035 in all three to get simplest ratio. So 4.07 by 2.035 equals to 2. It is 2.035 by 2.035, 1, it is also 1. So you see, simplest ratio is what? Our empirical formula. So we got empirical formula. Empirical formula is C1H2Cl1. So empirical formula we got. Question is empirical formula. Next is molecular formula. So first we will calculate what is N. So N equals to molecular formula mass divided by empirical formula mass. So what is the molecular formula mass given? That is 98.96 divided by empirical formula mass. So its mass, carbon 12, hydrogen 2, 14, chlorine 35.5 equals to 49.5. So it will divide, it is coming 2. So question is find molecular formula. So molecular formula equals to 2 into empirical formula CH2Cl. So formula C2H4Cl2. C2H4Cl2. Clear now? Okay, so like this what your question will come. So first question will read, then empirical formula, molecular formula, numerical we can solve by tabular method. First we will write element, atomic mass, percentage of mass, relative number of moles, and simplest ratio. Okay. So after calculation of this simplest ratio, we will get this. Sometimes you will see in the simplest ratio, exact whole number data will not come. So that's why another table will come, that is called a whole number ratio. Suppose you see, suppose 2, 1.5, 1. So that's why in 1.5, at least how much it will multiply so that we will get a whole number. So 2. So that 2 is multiplied in all three cases. 2 into 2, 1.5 into 2, 1 into 2. Got the idea? Okay. Come to second question. So second question is also same format. So you see, this is the first question over. Second question is, an organic substance containing carbon, hydrogen, oxygen gave the percentage composition carbon equals to this much, hydrogen this much, oxygen this much. If the vapor density of the compound is 59, calculate the empirical formula and molecular formula. So first you see same, first is element. So here element, how many elements? Carbon, hydrogen, oxygen. Then atomic mass. So atomic mass, carbon 12, hydrogen 1, oxygen 16. Then percentage of mass. So percentage of mass equals to carbon, how much given? 40.687, hydrogen 5.085, oxygen 54.228. And you will remember, sometimes question will ask carbon this much, hydrogen this much, and rest is oxygen. So if rest is oxygen means you have to add these two and you have to subtract from 100, so you get same thing. Okay. So next come to what? Relative number of moles. So relative number of moles. So 40.687 by 12, 5.085 by 1, 54.228 by 16. Okay. Next is simplest ratio. So simplest ratio. Okay. So here in this question 5 point, so it will come how much? 5.085. 5.085. If it will this, it is around 2 point something. Yes or no? It is around 40.12 means it is around 3.39 will come. Not 2, 3.39. It is also around 3.39 will come. So which one is lowest? This is. So divide. So here 3.39 by 3.39. 1. 5.085 by 3.39. It is 1.5. So it is 3.39 by 3.39. So it is 1. Now see. Whole number is not coming. So that's why whole number ratio. Whole number ratio. So 1 into 2, 2, 1.5 into 2, 3, 1 into 2, 2. Got it? So what is the empirical formula? So we got empirical formula is C2H3O2. Next, Vd given, vapor density. We know molecular mass equals to 2 into vapor density. So 2 into 59. Yes or no? So equals to 118. This is molecular mass. Next is what is N? So N equals to molecular mass 118 divided by empirical formula mass. So its mass is 12 into 2, 24. Hydrogen 3, 27. Oxygen 16 into 2, 32. So 32, 3, 35, 35, 24, 59. So it is also coming 2. So molecular formula equals to 2 into empirical formula C2H3O2. So it is C4H6O4. Clear? So like this, in this method we can calculate empirical formula and molecular formula. Clear now? Okay. So these are the concept. Empirical formula represents simplest ratio. Molecular formula represents the actual formula. Okay. For ionic compound, empirical formula, molecular formula are almost same. Okay, and in numerical we can solve by this method. Okay.